Okay, so for this video, we will be discussing another property of Laplace transform, so which is the multiplication by power of t. Okay, so for this property, so if we are given that the Laplace transform of f of t is f of s, then the Laplace transform of the product of t raised to n multiplied by f of t is equal to negative 1 raised to n multiplied by the nth derivative of f of s. Okay, so in this case, our n, okay, or the power of t should be whole numbers 1, 2, 3, 4, 5, 6, and so on. Okay, so how do we apply this formula? So find the Laplace transform of f of t is equal to t squared cosine 4t. Okay, so you're asked to find the Laplace transform of this. Okay, so obviously this is multiplication by power of t, so particularly t squared, so therefore our n is equal to 2. Okay, so we have to find f of s because later on we have to derive that. Okay, so our f of s should be the Laplace transform of this part, cosine 4t, okay, because that is the f of t in the formula. Okay, so the Laplace transform of cosine 4t is equal to, so from the formulas that we have already memorized, so the Laplace transform of cosine 4t would be s over s squared plus 4 squared, or s over s squared plus 4 squared, that is 16. Okay, so therefore the Laplace transform of t squared cosine of 4t is equal to, so following the formula, so negative 1 raised to n, so negative 1 raised to n is equal to 2 multiplied by the nth derivative. So since n is equal to 2, so this will be the second derivative with respect to s of s over s squared plus 16. Okay, so therefore we have to derive s over s squared plus 16 twice. Okay, so for the first derivative, so simplifying this first, so negative 1 squared, so that is 1. Okay, multiplied by, so first derivative of this, so since we will derive once, so therefore we have another that will remain, so it will become d over ds of the derivative of this. So using the product rule, the quotient rule, so we have denominator s squared plus 16 multiplied by the derivative of the numerator, we have 1 minus the denominator, the numerator s multiplied by the derivative of the denominator, so derivative of s squared plus 6, so 16, that is 2s over s squared plus 16 squared. Okay, so simplifying that, so that would be d over ds of, simplifying the numerator, so you have s squared minus 2s squared, so that is negative s squared plus 16 over s squared plus 16 squared. Okay, so another, so deriving this again, so we don't need to write this anymore, the d over ds, because our we only have to differentiate twice. So denominator is s squared plus 16 squared times derivative of the numerator, so you have negative 2s minus the numerator negative s squared plus 16 multiplied by derivative of the denominator, so using the power formula, so we have 2 times s squared plus 16 multiplied by the derivative of the expression inside the parenthesis, so that is 2s, okay, over s squared plus 16 squared and then square again. Okay, so as you can see, we have a common factor of s squared plus 16, so we can factor that out. So factoring s squared plus 16, so what will remain here is s squared plus 16 times negative 2s minus factoring s squared plus 16, so what will remain is negative s squared plus 16 and then times 4s times negative s squared plus 16, okay, over s squared plus 16 raised to the power of 4. Okay, so obviously we can cancel out 1, s squared plus 16, so therefore what will remain is the numerator. Let's simplify, distributing negative 2s here, so we have negative 2s cubed minus 32s, and then this will become plus 4s cubed and then minus 4 times 16, that is 64 minus 64s over s squared plus 16 cubed. Okay, so therefore simplifying, our Laplace transform now is simply 2s cubed and then minus, so 2s cubed minus, so we have 32 plus 64, we have 96, so minus 96s over s squared plus 16 cubed. Okay, or we can factor out 2s, so it's up to you. So we have greatest common factor is 2s, and then what will remain inside is x squared minus 96 divided by 2, that is 48. 96 divided by 2, yeah, so minus 48 over s squared plus 16 cubed. Okay, so this is now the Laplace transform of t squared cosine of 40. Okay, so that is very simple, and it will require you with your knowledge of course, the derivatives. Okay, so another example. Okay, so another example, so find the Laplace transform of f of t is equal to t times 3 sine 2t minus 2 cosine 2t. Okay, so for this problem, so you have two terms, so we have to distribute t, okay, for the first and second terms. So solution, now the Laplace transform of t 3 sine 2t, oops, sorry, minus 2 cosine 2t. Okay, so is equal to, so distributing the Laplace transform, so Laplace transform of, and also distributing t, so this will become Laplace transform of 3t sine 2t minus Laplace transform of 2t cosine 2t. Okay, so we have numerical coefficient, so we can take that out. So 3 Laplace transform of t sine 2t minus 2 Laplace transform of t cosine 2t. Okay, so again, this is multiplication multiplication by powers of t. Okay, so to get the Laplace transform of this, so we have to derive the Laplace transform of sine 2t once, and then the same with the Laplace transform of cosine 2t. So we have to take its first derivative also. So this will become, so 3. So using the formula, so our n is equal to 1, the exponent of t. So we'll have negative 1 raised to 1 multiplied by the derivative with respect to s of the Laplace transform of sine 2t. So the Laplace transform of sine 2t, so from the formulas that we have memorized, is equal to 2 over s squared plus 2 squared okay, so minus 2 times, so similarly with what we did here, so negative 1 raised to 1 multiplied by the first derivative with respect to s of the Laplace transform of cosine 2t. So the Laplace transform of cosine 2t is s over s squared plus 2 squared. Okay. Okay, so next is simplifying. So we have negative 1 times 3. So we have negative 3 multiplied by the derivative with respect to s of simplifying this. This is 2 over s squared plus 4 minus this one is it will become plus 2 times the derivative with respect to s of s over s squared plus 4. Okay, so performing the derivative, the differentiation, so we have negative 3 times, so derivative of the first term is equal to denominator s squared plus 4 multiplied by the derivative of the numerator 0 minus the numerator multiplied by the derivative of the denominator, so which is 2s times s squared plus 4 squared, okay, plus 2 times the derivative of the other one is, we have s squared plus 4 multiplied by the derivative of the numerator minus the numerator multiplied by derivative of the denominator over s squared plus 4 squared. Okay, so let us simplify. So we have negative 3 times, so the numerator here will become, so this is 0, so negative 4s over s squared plus 4 squared, then plus 2 times the numerator here will become s squared plus 4 minus 2s squared over s squared plus 4 squared. Okay, so we can multiply the constants so that we can add them later. So we have negative 3 times negative 4, so that is positive 12s over s squared plus 4 squared. Then this will become plus distributing 2 on each term, so this will become 2s squared plus 8 minus 4s squared, so this will become negative 2s squared plus 8. Okay, over s squared plus 4 squared. So since they have similar denominators, then we can add them directly. And then rearranging, so copy the denominator, so s squared plus 4 squared, so we have negative 2s squared plus 12s plus 8. Okay, or you can factor out negative 2, so it's up to you. So negative 2 times s squared minus 6s minus 4. over s squared plus 4 squared. So that is now the Laplace transform. Okay, so that's it. So if the term involves, or the function, okay, involves 2 or more terms, then all you need to do is distribute, okay, the Laplace transform. Okay, so that's all for this video. Good luck.